How are you all? I hope you all are doing wonderful. So as you all know that I have started with the JEE Main previous year question solving sessions, and each of the sessions I am discussing each and every topic of mathematics, and on each and every topic I am discussing the top 10 important JEE Main previous year questions which are very much favorable of coming up in your JEE Main paper. Alright, so as of that, so today's topic will be on permutation and combination. Now in the previous lectures, if you have watched me, if you have followed me for the previous times, then you must know that I have covered coordinate geometry and started with the algebra. And in algebra, I covered quadratic equation, complex numbers, and sequence and series. With this carry forward, I am starting with permutation and combinations. Alright, so permutation and combination is very important chapter. Alright, it has its roots in a binomial theorem as well as probability. So if you imagine yourself solving good level of problems, permutation combination is a very elementary chapter of mathematics, because many times in probability questions you will encounter questions where you have to calculate for the number of favorable cases or the total number of cases, and that are basically done by permutation and combination. So different kind of permutations and combinations are possible on based of which the numbers or total number of cases are basically made. So I hope you will remember these words and you can understand like how important permutation and combination is. Alright, so with this let's get started with the session number 9, that's on permutation and combination. So today's goal will basically to solve the top 11. So I took 11 problems, okay, important JEE Main previous year questions. Alright, so let's get started with that. So if you have been following me for a long time, then you must know what is the code of conduct. Just pause the video at this particular moment and try out the solution on yourself. Once you get to the answer, tally the solution with your solution and the MAINS solution and get to the answer. Now if you get the correct answer, we like move to the next one. And after all you're solving entirely done with this particular video, then definitely comment me in the comment section like how much score did you achieve after solving this particular lecture. Alright, so out of for example, if you grade it on +4 for the positive ones and -1 for the incorrect one, you can definitely let me know in the comment section, based on which I can access and everyone's situations. Alright, so let's get started with the very first problem, and the very first problem is on your screen. It says that the total number of 3-digit numbers, so it is basically specifying that you have to form 3-digit numbers, okay, which are divisible by 3. Again, it is saying that 3-digit number and that is to be divisible by 3. So let us assume that n is a 3-digit number and it is divided by 3, then it is basically a multiple of 3, okay, or it is better to write like this, that n is basically some multiple of 3, okay. That means when we divide by 3, the remainder is basically equal to 0. So if we divide by 3, that means it is something of fashion 3k, okay, where k is an integer, okay, where k is an integer. What you can understand from here is that when we divide n and take the remainder, so if you have studied programming, then you must know that remainder sign is basically this particular, and if you divide by remainder of 3, it is equal to 0. So that's the condition for remainder, okay. So now over here it is saying me that it can be the number are basically formed using the digits. So digits also specified as, so I will first write the digits. Okay, digits are given as 1, 3, 5 and 8. Okay, so I have 4 digits over here and I have to form the 3-digit number which is basically divisible by 3. And if the repetition of digit is allowed, okay, so another state is given that repetition of digits is allowed. So very first thing is that what is the divisibility condition? Divisibility by 3. Okay, a number is divisible by 3 when the sum of its all the individual digits or the consecutive digits are basically divisible by 3. That means, for example, you have a number which is basically a, b and c, where a, b and c are basically the corresponding digits. Then if n is divisible by 3, that means a plus b plus c, it is basically divisible by 3. And again I said that the condition of divisibility is basically when you divide by 3, the remainder is basically equal to 0. Alright, so based on this particular criteria, I will frame the entire problem. Okay, so let us understand. So if we form the divisible by 3, so what are the possible cases are there? So cases I will write. So the very first case is that if the sum of the digits is basically equal to 3. Okay, so this is a cases. What do you mean by cases? The sum of the digits. Okay, so what are the sum of the digits? Okay, the sum of the digits are basically different cases. Sum of the digit can be 3, can be 6, can be 9, and similarly can be 12, can be 15, okay, can be 18. And what is the maximum sum can be obtained? That is, if you add 8 3 times, that is 24. So the maximum you can go up to is 24. Alright, so when is the case that we basically get the sum of the digits as 3? That is, when you use the number like 111, okay, so you use this particular digit because it is said that repetition is allowed. That means when you use the digits, that is 1 3 times, the numbers or sum of the digit is basically equal to 3. So this corresponds to a one case, okay, because 111 can be permuted and can be formed only one number. Similarly, when the sum of the digit is equal to 6, so we have to look for the combination. Then if you look at the combinations, you will find that the sum of the digits will be 6 when the numbers are basically chosen in the fashion that is, so if you look for the sum of the digits as 6, so the number should be chosen in the fashion like 5 and 1, but that basically makes up a two-digit number. Okay, so there is no any case where you basically get sum of the digit at 6. That means this corresponds to the case of 0 cases. Okay, there are no cases corresponding to it. And similarly, if you look at what is the value 9, so 9 can be formed as using the digits 1 3 and 5, and also if you repeat 3 times, okay, so from here you will basically get how many cases. So if you see the three numbers which are distinct and unique, so from here you will basically get 3 factorial, and from this particular case you will only get 1 factorial, one number, okay, that is basically obtained by 3 factorial by 3 factorial, okay, because three are, they might not identical. So from here you will basically get 3 factorial is basically equal to 6, 6 plus 1 is basically 7 cases. So the sum of the digit is 9, so you will basically obtain 7 cases. And now similarly moving forward, when is the situation when the sum of the digits is basically equal to 12? So if you look at the case when the sum of the digits is equal to 12, that means you can form the case using the number of digits using 1 3, so 1 and 3 and 8, okay. So using this particular combination of digits, you can basically get the sum of the digits as 12. So from here you will again get 3 factorial cases, which is equal to 6 again. Similarly, let us look for when is the sum of the digits is equal to 15. So if you repeat 5, okay, 3 times, you will basically get the sum as 15. Otherwise you cannot get it, okay. So from here the 15 case, this will correspond to the number of cases, that is only one cases. This correspond to 6 cases. And similarly, when the sum is equal to 18, so if you look at sum for 18, we will get the condition that is 8, sorry, sum to be as 18, okay. So sum is 18 when you take 5 2 times and 8 1 time. So that is a possible case when you basically get the sum as 18. So this corresponds to the total number of cases, that is basically 3 factorial by 2 factorial, because two of them are identical. So from here you will get the cases as 3, okay. So 3 cases are possible. And similarly moving forward, also there can be a situation when the sum of the digits is equal to 21, okay. So if you look for 21, okay, you can definitely look for 21 as well, because so if you take 21, it can be formed by, so if you take 5 and 16, okay, so that is 8 and 8, okay. So there is also a case when the sum of the digits is equal to 21, but this will correspond to total number of cases, that is 3 factorial by 2 factorial, and that is again equal to 3, okay. And similarly for 24, when the sum of the digits is equal to 24, that is when you take 8 3 number of time, okay, so you take 8 3 times, then you basically get the sum of the digits is 24, so that corresponds to one possible case. Now, if we have to look for all the possible cases that can be formed using those digits, that are basically some of these possible cases. Okay, so if you look for total 3-digit number, okay, so I will specify 3-digit numbers which are divisible by 3, okay, are, so with repetition, the numbers are with repetitions, that is mentioned in the question, okay, with repetition using the digits, okay. So we use the digits 1 3 8 and 5. Using these particular digits, the total cases are, from the first one you get 1 cases, on the second you basically get 7 cases, okay, that is the sum of the digits is correspond to 9, because 6 cannot be possible. And similarly sum of the digit is equal to 12, that is 6 cases, okay, 6 cases. And similarly sum of the digits is 15, that is again 1 cases. And similarly sum of the digit is equal to 18, that is again 3 cases. And sum of the digit 21 is again 3 cases, again 24 is 1 cases. So that is 3 plus 3 plus 1, okay, and that will be a required answer. So if you sum up these results, so we'll get 14, 14 plus 1 15, 15 plus 1 16, and 16 plus 3 is 19, 19 plus 3 is equal to 21, sorry, 19 plus 3 is 22, okay. So there are basically 22 possible numbers, which are basically the 3-digit numbers and are divisible by 3 as using the following digits 1 3 5 and 8, and with repetition, of course. So with this I get the total number of conditions. From here I get the total number of cases or the answer to this particular problem is basically 22. With this, the option number B is the right answer to this particular problem. So with this, option number B is the right answer to this particular problem. I hope you have understood this particular problem, and you can definitely expect these types of problems are actually the only common problem that you can expect in your JEE Mains previous year paper. Okay, so actually number of digits, okay, and they are divisible by 3, or if they are divisible by 5, and using this particular condition that the digits are only limited between like some of the cases, so they are the most favorable problem that are basically you can encounter in an examination. So I hope this is an important problem, and you must have understood the way to solve this particular problem. Okay, so with this, let us move to the next problem. All right, so the next problem is again a very important problem. So if you have studied the chapter, you must have solved this problem as under the name, that is a dictionary rank of a word. Okay, and many of you might have studied like formulas or shortcuts for finding the rank of a dictionary rank. Okay, but I would say there is no need to remember those particular shortcut. Okay, those shortcuts are good for like getting the answers, or you can definitely play a trick on your friends. Okay, but the shortcuts doesn't apply in examination purpose, because you then again have to remember one important thing as well. Okay, so every time it is not feasible. Okay, as well as in the examination situation, it may have give you a different case. Okay, like I will be taking up an important problem in today's session only, where I will be explaining you that formulas won't work everywhere. Okay, those formulas which I have marked up won't work everywhere. So let us study the given word. So it is said the given word, it is said that all words with or without meaning. Okay, so here it is a very important thing, that is in dictionary you will find only words with given meaning, but in mathematics, or when we are able to permute for each and every word, so we have to form all the words that are possible, that are with or without meaning. So it is not an actual dictionary rank, but if you arrange these numbers alphabetically, you will get some kind of serial number, and that's what we are basically to find. So using the word is basically Monday. Okay, a very important day after Sunday. Okay, so Monday, and these words are basically written in a dictionary with a serial number. Okay, so you have to look for what is the serial number of the word Monday. All right, so let me understand like how can you get Monday. So before solving for Monday, we need to look for what is the alphabetical order. Okay, what is the alphabetical order of the letters? So the alphabetical orders of the letters are basically A, then D. Okay, A, D, then comes M, then comes N, then comes O, then comes at last Y. So that is the alphabetical order. So whatever the words are formed and arranged in a dictionary, that are basically arranged in an alphabetical order. Okay, alphabetical order. So from here, if you look at the words that has basically A in the beginning, okay, A in the beginning, or the number of words, so solving the dictionary or rank of a problem is very straightforward. So you have to remember this particular straightforward approach, that is the approach when you have to take all the cases until you get M in the first one. So if you look at the words that can be formed using A, are basically the, so if you take A in the beginning, so you are left with the letters are 1, 2, 3, 4 and 5. 5 letters are remaining. So all the words which are A in the beginning basically have the 5 other letters which can permute themselves as in a fashion of 5 factorial, and that will definitely yield you 120 words. Okay, and similarly if you look at the all the words which has D in the beginning will also have 5 factorial ways of arranging themselves, and they will have 120 words again. Okay, now if you look at M, so M is the required word that you need to look for, because we have to look for the rank of Monday. So we got M. Now we have to look for what are the possible cases when M has A is the second letter. So M and A as a second letter, this can be permuted as 4 factorial ways, and that will be 24 words. Okay, and similarly you have to look for the number of words which has M and D as the first letters. So if you look at M and D, okay, M and D, then there will be again 4 factorial ways, and that is 24 ways. Similarly, you have to look for the case when M has N in it. Okay, because we have to look for alphabetical order. So alphabetical order, if M is fixed, then you will choose for the next alphabetical order, that is A, D, and then again we follow the same pattern. I hope you are understanding this particular way. So then we have to look for M, and then which has N after a words. So this will again have 4 factorial ways, and that is 24 words. Now similarly, if you look and go on alphabetically arranging it, then we have M, after which it will have O. But since O is again fixed for the word Monday, so we have to look for the next possible case of alphabetical arrangement that has A to it. that is MOA. So MOA, so the words which are starting with MOA as the first digits will again have, now how many ways they can be arranged? There will be again possible 3 factorial ways, and that is again equal to 6 the words. Similarly, we move forward and then we will have MOD as the word. Okay, but if you look at Monday, if it has MON, now after the alphabetical order is followed, so after MO, so MO is fixed. Next, MO is fixed, then we have to look for again alphabetical order. So it will have A as the alphabetical order, and after A it will have D as order, so that means MOD. Okay, and we have to look for all the words which has basically MOD in the starting letters, and this will again be 3 factorial ways, and that can be 6 words. Similarly, if you look on, then after D, the MO is fixed. After D, the alphabetical fashion is order is basically N, and N is again present in one word Monday. That means MON is again fixed. Now we have to look for the words which has basically A to it. Okay, now to look for the words which has basically A after A word it's. So we have to look for the word which has MONA as its first 4 letters. So this can be permuted in 2 factorial ways, that is basically 2. And similarly, if you look forward, then it will have MON, then after A the alphabetical order for D, and D is also present in the word Monday, and then for you will have D as a fixed case. Then you will look for what is the case afterward proceeding to it, and it will again have A again to it, and A is also fixed in the word, so MONDA is fixed. Now you have to look for the what is the afterward the alphabetical order which is left is Monday. That means you obtain the word like this. So after this particular 2 words, you will exactly have this word Monday. So after these 2 words, you will have the word Monday. That means you have to consider this word as 1, and with this you have to report the rank of the word as, okay, rank of the word. What is the word? The word is Monday. So the rank of the word Monday is equal to 120 plus 120 plus, then you have to look for 1 2 and 3 times of 2 24, so that is 3 into 24 plus how many times 6 present, 6 are present 2 times. Okay, so plus 12 plus 2 plus 3, so that is, and if you sum up, this is 240 plus, if this is if it is solved out, this will be basically 72 plus 12 plus 3, and if you solve for this will be 300 and 326. Okay, so if you look at this answer will be 306. Okay, 306. Okay. Okay, so there is another important thing that you must remember. Okay, 306, this is basically not 1 2 over here. Okay, last digit will be 2, so you have to consider that the after all it is a rank. Okay, so you have to consider the rank is basically all the letters up till here. Okay, so you have to consider all the letters up till here. So this will be the word Monday, so up till here this will decide the rank, and plus 1, this will be the current serial number. Okay, so if you look for rank is basically up till over here. Okay, because if you consider this as first word, second word, and so on as this. Okay, so you will have the rank up till over here. Similarly, if you look at the serial letter, it will basically have the serial letter, that is 1, and for this you basically adding 1. So up till here you have to basically add, that means for here it will be 2 plus 1, that's what I was explaining, that as 3 over here, and similarly this will have plus 1 to it, and that will be basically 273. That is, if you compute this result, not this is the result that you compute, so the answer to this particular problem is basically equal to 327. Okay, 327. So if you compute this result, okay, this is basically 327, because you have to consider for the serial number, and serial number are including this particular word. So this particular, after this particular word, it will have serial number which is count as 1, and if you add 1 to the end, because many students forget to add 1, they report the answer up till over here, and if you add 1 to this, then you basically get to the required serial number or the rank of the word, that is basically asked, and the answer to the rank of the word will basically 327. So 327 is the right answer to this particular problem. So I hope if you have solved this particular before than me, and you have got the answer as option D, then a plus 4 to your bucket. Alright, so this is a very important problem. Okay, so dictionary problems are very important, because you will find dictionary problem getting repeated many number of times. I hope you have understood this particular problem and have enjoyed this particular problem. Okay, so with this, let us move to the next problem. And the next problem is again a problem which is basically a problem of a number. Okay, you have to look for the 5-digit numbers. Okay, so again specified, it is basically 5-digit number. So we have to look for all 5-digit numbers which are greater than 40,000. Okay, now 40,000 again a 5-digit number. Now all the numbers of 5-digit numbers which are basically greater than 40,000 and are also divisible by 5. Again, the criteria for divisible by 5 by 5 is that the last digit, okay, the last digit is the last digit of the number is basically 0 or 5. Okay, so the last digit of a number is 0 or 5. Now if you want to in programming approach, if you look at this, so if you in order to get to the last digit of a number, so for example there is a number n, and if you have to get to the last digit of a number, you basically do it divide by, okay, you just need to divide it by, sorry, you just need to take the remainder by 10. Okay, you just need to remainder the 10, and the result will be the last digit number. And if this last digit number is also divisible by 5, is divisible by 5, that means basically equal to 0. That is a condition when you look for programming approach. Okay, so I'm also giving you the programming approach as well. Okay, because many students in class 12 might have taken computer science, and they might have to basically take these cases. Okay, so that's the programming approach. Okay, okay, apart from this, so we have to look for the last digit is basically 5 or 0. Now, what are the possible cases? We have to look for the 5-digit numbers, and the digits are also specified in the problem. And the digits are also specified in the problems. Okay, digits are, okay, allowed digits are 0, 1, 3, 5, 7, and 9. They are the possible digits. Now, since this number must have these following digits and also should be greater than 40,000, also divisible by 5, that means the number possibles, okay, there are possible configuration are. So if you look at the possible configurations, what are the possible configuration of numbers? So if you look at the possible configuration number, that will have the first digit starting with 5. Okay, because if you have the first digit starting with 1 or 3, they are not the possible case, because the number must be greater than 40,000. That is the possible cases that has 5, 7, okay, and 9 as the first digits. All right, so if we look at these are the possible cases for the first digits. Okay, so these are the first digits. Okay, these are the possible case for first digits. First digits, possible case for first digits. Now the configuration of the numbers will be basically, so there will be 5 at the first, and then there will be some numbers, so 1, 2, 3, and there will be 0 at the end. Okay, so must have 0 at the end. So similarly for 7 at the first digit, there will be the configuration as something like this 0, or there will be configuration as 7 this somewhere over here, and then again have it as 5 at the end. Okay, similarly correspond to 9, there will be the possible cases that is something like this, or the possible configuration which has last digit 0, and possible configuration which is last digit as 5. Okay, so these are the possible, so we can count it that there are total 5 possible configuration which can be are actually allowed. Now if we follow for each of the configuration, if we try to count the number of cases, okay, so for this particular configuration, if you look at the cases, that is the remaining digits are, how many digits are present. Okay, so to look for the digits are 0, 1, okay, 0, 1, 3, 5, 3, 5, 7, and 9. So 1 is 0 is also already used, and 5 is already used. So you are left with 4 digits. Okay, 4 possible digits. Now in 3 places you have to put 4 possible digits. That is basically done by firstly choose 4 digits out of this. Okay, so firstly choose 3 digits out of this 4 digit. So if you choose 3 digits out of the 4 digits, that is 4C3, and then permute in 3 factorial ways. So the multiplied with 3 factorial. That is a possible case for this, and this will be 6 into 4, and that is equal to 24 ways. Now corresponding to the configuration is 7, that is has this particular as the end as 0. So there are the possible cases are, so it has 7 and 0 as utilized case. So we again left with 4 digits, and the 4 digits can be arranged in 3 ways. Okay, 3 factorial ways, and that is again is equal to 24. Now similarly for this particular case, okay, which has last digit are 5, again we'll have 24 cases. Okay, that is 4C3 into 3 factorial, and that will be also equal to 24 ways. Okay, similarly, if you look at 9 with the 9 and ending with 0, this will also have 24 cases. Okay, and similarly, the number 9 in the first digit and the ending digit as 5 will also have again 24 cases. Okay, so with this, you basically get the total number of cases that are basically, so total possible numbers. Okay, total possible numbers are basically equal to, so there are 5 configuration, and each of the configuration has the cases as 24, so that is 5 into 24, and the answer to this particular will be equal to 120, and the answer to this particular value will be equal to 120. So that means you will basically have 120 different possible numbers which are basically formed using the digits 0, 1, 3, 5, 7, and 9, and they are greater than 40,000 and also divisible by 5. So with this, the right answer to the particular problem will be basically option number C. Okay, so I hope you have understood this particular problem. Pretty straightforward problem, and again an interesting problem. Okay, so let us move to the next problem. All right, so the next problem is what the problem that I was talking about. Okay, so many students actually remember the formulas for dictionary rank or the serial rank of any word, but many times the question will be asked that if the letters of the word maths, okay, so there is a word of the letters maths, okay, they are basically permuted in each and every possible ways, and they are arranged in a dictionary. And in the dictionary, you have to look for the serial number of words that will have the word themes. Okay, so if you look at this, these are basically the using form. The word actually formed using the letters of the words maths. Okay, so if you look at this particular word maths, then if you jumble this, and then you will have the word themes. Okay, so to look for the serial word when maths are basically permuted in. Okay, so if you look at the total words, total letters, so there are basically 5 letters. Okay, so if you look at, there are total 5 letters. Okay, 5 identical letters, sorry, 5 distinct letters. So better to write as 5 unique letters. So we have 5 unique letters. Okay, so we will have 5 unique elements or letters. Okay, or letters. Okay, so there are 5 unique letters, and using these 5 unique letters, total words that can possible are total words possible. Okay, total words possible are basically 5 factorial, that is 120. Okay, so out of this 120 numbers, what is the serial rank or the word themes? So to look for the serial rank of the word themes. Now before doing so, let me firstly again get the alphabetical order of the letters which are present. So if you look at the alphabetical orders of the letters present, that will have A. Okay, so the letters will have alphabetically arranged as A, then it will have H. Okay, then it will have M, then it will have S, then it will have T. Okay, so these are the basically alphabetical order in which the numbers will be arranged or and permuted in kept in the dictionary with the serial number. Now we have to look for the cases. Okay, now we have to look for the cases basically. So the cases of the ways are basically when we permute in each and every word of the maths. Okay, so from here the letters, so we have 5 letters in the word max, and if we fix the letters, there are, so if we fixed each of the letters, so for example if we fix the first letter in the position, then we basically have 4 cases, and that will be arranged in a 4 factorial ways, and that is basically 24. Okay, to arrange the remaining letters, the letters before T, so the letters before T, so all the letters before T will be arranged in 24 ways. Okay, all the letters which are basically before T will be arranged in 24 ways. So that means we have all the words before A will have the words like the first word will be starting with A, the second letter will be H. Okay, the third letter, the word with the letter starting with M, the word with the letter starting with S. So they will all have 24 cases. Okay, they will have 24 cases. They will again have 24 cases. Okay, now after this, the word that start with the letter T will come, and now the word letter T, then we basically have the word as with letter TA. Now if we look at the word with the letter TA, it will have again 3 factorial ways of arranging, and there will be 6. Now with this we have to look for the next possible case, that is TH. Now the TH is present in the word THAMS. Okay, so to look for the letter of the serial rank of the word THAMS, so it is again present, TH is present, and after TH of course the letter will be A, and after A the letter will be given will be M. Okay, and similarly after M the letter will be given as H, S. So I hope, and after this is the required number, that is the required word that we need in this particular, so that will be basically the one. Okay, so that is the serial number 1. It will have the plus 1 also up till here, whatever the number is summed up, and then it will have the 1, so you have to add 1, and with this you will get the serial rank. Okay, the serial number of the word THAMS really basically, that is 4 into 24, so 4 into 24, 4 into 24 plus 6 plus 1, and that will basically equal to, so if you sum up, the result will be equal to, so 4 into 24 is equal to 96, 96 plus 6 102, 102 plus 1 is equal to 103. So with this you will get the serial rank of the word THAMS that will be arranged by the letters of the word maths. Okay, are basically 103. So if you arrange all the possible letters of the word maths, you will basically get the 103rd position. The word that you will get is basically THAMS. So with this, the corresponding answer to this particular problem will be option number A. So I hope if you have solved this particular problem, you will get the answer as option number A. So this is a kind of a unique question. Okay, not very simple to a problem that we basically solved as the dictionary rank. Okay, So it has some kind of a mix match. Okay, so I hope this is again an important problem. So you will remember this particular approach of solving this particular problem. So with this, let us move to the next problem. All right, so the next problem is basically to find out the number of triplets. The triplets is basically the number of set for this particular number, that is x, y and z, where x, y and z are distinct non-negative, okay, distinct non-negative, okay, they are non-negative integers. All right, and they satisfy the condition, that is x plus y plus z is equal to 15. So based on this particular equation, we need to find for all the possible values of x, y and z. All right, so it is a very important problem. Okay, so if you look at these problems, and since this problem involves the coefficient of x as 1, coefficient of y as 1 and coefficient of z as 1, so it creates a simplicity. All right, and many teachers, are like, if you study different books, you will find out these methods are also labeled as, like, one of them has called this a ball stick method, one is called as like beggar's method. Okay, so there are like lot of approaches to it. But if you look at the mathematics for it, okay, you will find the approach is basically the correct approach to this particular solution is basically by the multinomial approach. Okay, so I won't be talking about that. Okay, so let me understand like what to get from here. So first of all, x, y and z, all of them are positive integers. Okay, and all of them are, they are not basically same. All right, so for the cases, okay, we need to form some cases. So let me understand, like whenever you have given a problem like this particular fashion, when, so let me write this. Okay, so if you have studied the chapter, you may directly know the how to write the solutions. Okay, so if x plus y plus z is equal to 15, so what is the number of cases? You will directly remember this particular formula. Okay, I will tell you the formula to remember is basically, so there are total 3 variables. Okay, and all 3 of the variables have no other condition except that they are positive. So the total solutions, okay, so this is very important. I will let you that to remember this. The total solution is basically 15 plus 3 minus 1 c 3 minus 1, and if you evaluate this value comes out as 17c2. Okay, and the value of 17c2, so if you calculate the value of 17c2 is basically 17 into 16 by 2, and if you cancel, this is 8 into 17, and that the result is 136. Okay, so from here you'll basically get 136 results. Okay, now the problem is, now we need to exclude the cases. We need to exclude the cases when x is equal to y is equal to z. Now these are the solutions. These are the total number of solutions for which x, y and z are satisfying this particular equation, that is x plus y plus z is equal to 15. So from here, so from those 136 solutions, we need to exclude, okay, exclude distinct solutions. Okay, I mean, we need to exclude the, sorry, not the distinct, we need to exclude the identical solution. So from here, I will write it as, we need to exclude the identical solutions. Okay, so that is the case when any of the two of the variables are basically same. So let us first consider the case when x is equal to y but they are not equal to z. Okay, so let me consider for this particular case. So if you look at this case, if this particular case holds true, then the equation basically becomes 2x plus z, 2x plus z is equal to 15. Okay, 2x plus z equals to 15. So from here, 2x plus z is equal to 15. Alright, so if you solve this particular, and now you can go on forming some cases. Okay, that is for x is equal to 0, z is equal to 15. Okay, similarly for x is equal to 1, z is equal to 13. Okay, and so on, you can form cases. Okay, so if you go on forming cases, you will get x is equal to, y is equal to, sorry, z is equal to, in the similar fashion you will get z is equal to 11. All right, and similarly if x is equal to, so if we write x is equal to, 3, z is equal to, so how much, what will be the value of z? The z value will be equal to 9. Similarly x is equal to 4, z is equal to 7, and x is equal to 5, then z is also equal to 5. But that is not the case, because we are considering x is equal to y but not equal to z. Similarly if x is equal to 6, z is equal to 3. Okay, z is equal to 3. Similarly if x is equal to 7, z is equal to 1. Okay, so there are like 1, 2, 3, 4, 5, 6 and 7 solutions which need to be excluded. And similarly the cases can be repeated for the other 3 as well. But that is there are, so if you see of these particular cases, that is x is equal to y but not is equal to z, so also there can be a situation when x is not equal to y but it is equal to z. And similarly there can be a case when x is equal to z but not equal to y. So there are like 3 cases, and each of the 3 cases will have 7 different values which need to be excluded. So total number of triplet you will see that is basically 136 minus the result that you need to subtract it, basically 7 into 3, because there for each of the cases corresponding to cases when x is equal to y but not equal to z, or similarly if x is equal to y x is not equal to y but is equal to z, and similarly x is equal to z but not equal to y. So for these 3 different cases there will be all total 7 different cases which need to be excluded. So that is 7 into 3, and the value will be coming out as 136 minus 21, and from this you will get the result as 100 and 115. Okay, so from here you will actually get the result as 115, but that also excludes one more important result, that is when x is equal to y is equal to z. So x is equal to y is equal to z, that is all of them are equal to 5, and that is also a case which you need to exclude out. So you will subtract -1 also. So from here if you subtract -1, the answer to this particular problem you will get it as, so from here if you subtract the answer you will get it as 114, and with this the right answer to this particular problem will be option number D. Alright, so quite an important problem. Okay, by directly looking at this particular problem, many students will directly apply this particular formula and they will get the answer as 136, and also it is present in the answer. So they will see that option number A is the right answer and they will go on, but they will eventually understand this is the wrong option, because they have to look for the distinct solution, that is none of them can be identical, that is x is equal to y is equal to z is not possible. Similarly no two of them can also be identical. So that is the thing that you need to ensure before you are marking your answer. I hope you will understand this particular problem. So let us move further and study the next problems. So the next problem says that there are total 8 persons that need to be transported from city A to city B. Okay, so let me draw the situation. So there is a city A, okay, and from city A to city B we need to move 8 persons. So there are 8 persons, okay, which need to be moved from city A to city B in 3D cars of different makes. Okay, so there are like 3 cars. Okay, so there are like 3 cars and each 8 person has to be moved from city A to city B in these of the 3 cars. And if each of the car can accommodate at most, okay, at most 3%, each of the car can at most accommodate 3 persons, the number of ways in which this can be transported. So this problem can also be done by like forming the equation. Okay, but what I will say, like let me understand, let me instead of doing in equation format, we can also write this as in the following way, like let the car be, okay, let the cars be, one of the car be labeled as C1, other car is C2, and the third car be C3. Okay, now all of them C1, C2, C3 can have a maximum of, C1 can have maximum of 3 people, C2 can accommodate a maximum of 3 people, and similarly C3 can accommodate a maximum of 3 people. Okay, so that is the condition for transportation of people from city A to city B. Now let the number of people transported on C1, C2 and C3 be like this particular fashion. So let the number of people who transport on C1 be like 3 people, okay, C2 be like 3 people, and similarly on C3 be like 2 people, because 3 plus 3 6, 6 plus 2 8 people. Okay, and if you look at this particular way, so what are the different ways of arrangement is the only the required solution for this particular problem. So this problem is actually a problem of grouping. Okay, so you have to group 8 people into 3 different bags. So you must have studied these particular cases that whenever we are basically have n number of objects and we need to group into r identical bags, such that each of the bag has r1 of r1 bag has r1 objects, r2 bag has r2 objects. Okay, so like similarly this particular objects, okay, and so on up to r of k, some like r of k there, sir. So this is basically a question of grouping. Okay, we need to basically group the number of people into different ways. Okay, so what is the total way of grouping these people can be basically looked upon. So if you see, the 8 people can be grouped in the fashion 3, 3 and 2. Okay, is there any other possible cases? If you look at like 2, 2 and 2, so that can be basically equal to 6, so that cannot be a possible situation. Similarly 2, 2, 3 is also not a possible situation. The only possible cases, so I will write this as possible situation. Okay, possible solution is when 8 people goes into 3, 3 and 2. Okay, and from here if you look at this grouping of 8 people into a group of 3, 3 and 2, you will get the total values as total ways of grouping. So if you look at the total ways of grouping, so it will basically 8 factorial whole divided by 3 factorial into 3 factorial, and how many times 3's are present, so that is 2 times, so we will again multiply with 2 factorial and into 2 factorial. Okay, so if you look at the solution, the answer will be 8 factorial by 3 factorial whole square divided by 2 factorial whole square. So if you can definitely, and then there another thing is very important, that is once you are done grouping, okay, now once you are done grouping, it is said that each of the cards are identical. Okay, it is said that, let me use this color, it is again saying that each of the card are identical. So each card are identical, that means they are distinct from the other one. That means if you look at this particular grouping, so there can be a group in which the C1 has 3 people, C2 has 3 people and C3 has 2 people. Similar cases can be formed like C3 has 3 people, C2 has 3 people and C1 has 2 people. So there can be grouping based on the card. Okay, so there will be basically grouped into, and they definitely can be, now I will not be using the grouping word, the total ways of so the question is the total ways they can be done, total ways of doing the arrangement. Okay, so let me write this as arrangement. So total way of doing the arrangement is basically once you are done with the grouping, then you need to multiply with the total possible permutation. So if you look at the total possible permutation, that is 3 cards are present, so that can be multiplied with 3 factorial. So from here, if you calculate this result, you can calculate as 3 factorial will cancel with 1 on the square, and 8 factorial divided by 3 factorial into 2 square. So 2 square is 4. So if you do this particular calculation, and you will find out the result is 1680. So there will be a total of 1680 ways. Okay, so there will be a total of 1680 ways. So with this, the right answer to this particular problem will be option number B. Alright, so from here you will get the answer as option number B. I hope this particular solution is clear. Alright, so with this, let us move to the next problem. And the next problem says that if there are the number of words which are formed with or without meaning that can be formed using the letter of the words mathematics. So we are given the word as, so given word is basically mathematics. Okay, so let me write the word. So the given word is mathematics, and you have to form the words. So number of words that can be possible which are with or without meaning, which make use of all the letters of the words mathematics, in which C and S do not come together. Okay, so there is another thing that you must also know. If we are given with a set of event of A, and the cardinal number of set of event A is basically or, and if I say that cardinal number of bar of set A, that is except set A, whatever the number is present, and this is basically equal to 1 minus cardinal number of set A. So you must have known this particular way. Okay, so that means if I say the total number of words in which C and S are together, okay, in which C and S are always together, is not the required case. That means 1 minus the cases in which C and S are always together is basically the required answer. So I will say the total ways or total words possible is 1 minus cases when C and S, the letter C and S comes together. Okay, comes together. So I need to solve for the cases when the letter C and S comes together. So let me understand how can we solve this particular problem. So if you look at the letter of the words, okay, mathematics, the total words that can be permuted, total words possible. Okay, so total number of words which are possible. If you look at this word mathematics, there are actually 11 letters, and out of these 11 letters, there are 2 letters, that is A, of same kind. Similarly, M is 2 times present, and similarly T is also 2 times present. So that is divided by 2 factorial, divided by 2 factorial, divided by 2 factorial, because there are 3 letters which are present 2 times. That is M, A, and T. Okay, so from here you'll basically get the total cases or total number of words that can be possible using the letters of the word mathematics. And now we have to look for the cases when C and S comes together, are together. So we need to look for the cases when the letters C and S are together. So if you look at the C and S are together, then you need to use the concept of bundle method. I hope you have understood this bundle method and the gap method. Actually, if you have studied the chapter of permutation and combination, then these are the terms which are very useful. Okay, so whenever we need these two particular things are always together, let us put them in a bundle. Okay, or let us tie them using a thread and put them and treat them as a identical quantity. So if you treat them as an identical quantity, that is C and S as identical quantity, and accept all the words, okay, and all the words are treated as individual words, so there can be total cases or the total words possible, total words possible. Okay, so total words which are possible are basically equal to, then instead of taking C and S as different letters, they're actually grouped as the same letter, so that will be reducing the total number of letters as 10. And if you look at out of these 10 letters, there will be basically again M is 2 times present, A is 2 times present, and T is 2 times present, so that will be the total cases when C and S are together. Okay, now there can be another way, that is instead of C and S, they can make case when S and C are together. Okay, S and C are together, so that is basically they can also be again grouped into two different ways, that is again multiplied with 2 factorial, because the grouping of C and S can also be done in two different ways, like which is present in the first and which is present in the end. Okay, so that can also be grouped into different type. Now the required solution, okay, the required solution or the required words in which C and S are not together, we need to subtract the total cases, we need to subtract. So this is basically 1 minus, so I wrote it 1 because in terms of like 1 is a universal, so let me write this better. It is better to write this as, okay, it is better to write this as cardinal number of universal set. Okay, cardinal number of universal set minus cardinal number of the set A. Okay, so from this, you from here you will get the result. So from here you will get the result as total number of cases, that is 11 factorial divided by 2 factorial into divided by 2 factorial divided by 2 factorial minus the cases when C and S are together, that is 10 factorial into divided by 2 factorial into 2 factorial. Okay, now from here if you solve this particular, then you will basically get the required answer. And if you can solve this as by taking 10 factorial divided by 2 factorial divided by 2 factorial as common. So if you take this, this is the result you will get as 11 by 2 minus of 1. So from here you can solve this. Okay, so from here this will be 10 factorial divided by 2 factorial into 2 factorial into, and this particular result will be giving as 9 by 2. So from here if you can solve this, so this is basically, and it is said in the answer, it is that is the total cases are basically 6 factorial times of k. So from here we have to group as, so this is 6 factorial into 7 into 8 into 9 into 10 into again a 9 and divided by, so there is 2 into 2 into 2, so that is 8. Okay, so from here 8 and 8 get cancelled, and this is 6 factorial into k. So the k value is basically this particular number. So if you look at this value of k, so you can definitely calculate it as 81 into 7 into 10, and this result will basically 5670. Okay, 5670. And from this the value of the k for this particular given question is basically option number A, and that is 5670. So with this, the right answer to this particular problem will be option number A. I hope you have got this particular problem. It's quite a simple problem but very important problem. Okay, now similar problem is also where asked in the same year, okay, but in different shift. So you can take this particular problem as a homework problem. Okay, so you can take this particular problem as a homework problem. It is also saying that the number of arrangement of the letter of the word independence in which all the vowels, okay, so instead of telling the letters, it is telling you that all the vowels are basically not always together, not always together. Okay, so you have to look for the cases when 1 minus the cases when all the vowels are together. Okay, so you have to look for, so from here if you look at the vowels, so if you from this particular word independence, if you look at the vowels are basically I, E, and E is basically present. If you look at the word letter E, 1 2 3 and 4 times, so E is basically present 4 times. So you have to look for the cases when, so in the problem it is asking you the cases when all the vowels are not always together, that is 1 minus the, sorry, not 1, that is the total number of words minus the number of words in which all the vowels are together. Okay, minus the cases in which the vowels are together, so you can directly get the answer from there. Okay, so I am leaving this particular problem for the homework, and definitely comment me in the comment section with the right answer to this particular problem and how you approached it. Okay, so I will be very happy to welcome your comments. Okay, so with this, let us move to the next problem. All right, so the next problem is again a problem which is very important. Now this is a problem on grouping Okay, grouping in circular table. Okay, so this is also important. Circular table, that is question of circular permutation. Okay, so the question of circular permutation. Okay, so it is saying that there are total of 5 girls and 7 boys. Okay, so 5 girls and 7 boys can be seated in a round table so there are a total of 5 girls and 7 boys can be seated in a round table so that no 2 girls all sit together. So what are the basic cases? Okay, so if you have the total boys as 7 and total girls as 5, so you have to look for that is whenever now in permutation and combination, in question of permutation, we have to look for that no 2 girls sit together. You basically need to solve for the case, that is basically you firstly arrange the boys first, and in the gaps of the boys you have to arrange all the girls. Alright, so whenever you have a straight line, okay, straight line, and if there are, so 1 2, so let me say that there are k objects. Okay, so there are k objects, and in these k objects if you look at the gaps, okay, in these k objects the gaps present are basically k plus 1. Okay, but in a circular table when there are k objects arranged, the total number of gaps which are present is equal to the number of the objects, and that is equal to k. Okay, so instead of the linear fashion, okay, this is in a linear fashion, this is a linear fashion. So in place of a linear arrangement, if the arrangement is done in a circular manner, the total number of gaps are basically is equal to the number of objects. So from here, if you have to arrange the 5 girls and 7 boys such that no 2 girls are sit together, let me first arrange the boys. So this is boy number 1, boy number 2, boy number 3, and so on up to boy number 7. Okay, now what is the total number of ways of arrangement? Now total ways of arrangement, okay, of boys. So if you look at the total number of ways of arrangement of the boys, again, this is a concept of circular permutation. So in a circular bed, okay, if you consider circular arrangement and if there are k objects, okay, if there are total of, like there are k objects, so total ways of arranging this k in the, so all of them are identical. So the total ways of arranging, total arrangements are basically k minus 1 factorial. Okay, k minus 1 factorial, because the very first object is gone. Whenever we choose the very first object, that particular object basically decide the number from which the rest of the numbers are actually arranged. So for example, if I say that there is a circular table, because in a circular table there is no end point or there is no starting point, so we have to use any one object, we have to use that particular object, we have to send that particular object in order to decide the starting and the end point. I hope you will be getting this if you have studied the chapter or try to understand like what I am speaking. I am speaking that the one of the object is basically utilized, one of the object is utilized in determining the position of the first or the last element. Because in a circular table there is nothing as this is the first and this is the end. I hope you will get from here. And then the total ways of arrangement of the boys is basically 7 boys are present, so the arrangement will be basically 6 ways, 6 factorial, and in these 7 ways there are basically 7 gaps. Okay, so out of these 7 people boys, there will be basically 7 gaps. So in these 7 gaps we can arrange or we can make the girls to fit in there. That means total ways. So let me erase this and write over here the total ways of arranging girls can be is basically equal to, firstly 6 factorial is for the boys. Okay, this is for the boys, so I am writing b into, and out of the 7 gaps, let us choose 5 gaps out of the 7 gaps. So I am writing this as choosing of gaps. Okay, choosing of gap, because in permutation and combination you will see now there is no very much of mathematics or logic involved. Okay, sorry, logic is involved, but I'm talking in terms like you will see that there are multiplication and addition, that is overall you need to do the mathematics in this particular chapter, but whatever is involved is basically the concepts. Okay, so there is not very much of like difficult maths you need to do. Okay, so many where if you find solution in the book you won't be able to understand like which particular things is multiplied over here and then they are adding to some factor. So that is the most difficult part of permutation and combination, but I am writing everything in detail. So this 6 factorial stands for the boys arrangement, this 5 and c5 is basically choosing of the say gaps, like there are 7 gaps, and out of the 7 gaps we have to choose for 5 gaps, so that is basically done by 7c5, and in these 5 gaps we have to arrange the girls, so again this will be 5 factorial. This is the basically girls arrangement. Now you will ask me definitely a question that why for the girls case we need to use for 5 factorial, why not 5 minus 1 factorial? Okay, so that is a question, but in this case of arrangement of girls we already have the position as fixed. Okay, now once the boys are arranged, okay, once boys are arranged, we already have the seats, we already have fixed number of seats. Okay, I mean to say the arrangement is fixed, or there is no question of coming like choosing the first one or choosing the end point or the first point. That's why we need to directly multiply with 5 factorial. Many students make mistake over here. Okay, so I am pinpointing it out everything in detail, and with this you can understand like how much effort I am putting in this making this particular video. So with this you'll get to the right answer to this particular problem, and now from here you'll actually get the right answer. Alright, so if you solve this particular value, okay, you can definitely solve this, and the result of this particular problem, okay, then the result of this particular problem can be, so let me solve it here. Okay, so it is 7c5, okay, and 7c5 value is also corresponding to 7c2, and 7c2 is basically 7 into 6 by 2, so that will be coming out as 21. Okay, and 21 into 6 is basically 126. So from here you will get the right answer to the particular problem as 126 into 5 factorial into 5 factorial, because I am writing 6 factorial as 6 into 5 factorial. Okay, 6 into 5 factorial, and this result if you compute with 5 factorial, the result you will get 126 into 5 factorial whole square. So with this the right answer to this particular problem will be option number D. I hope you have got this particular problem. So I think I have explained a lot in this particular problem. Okay, so by this particular explanation you must have understood like how you can definitely make mistakes in the examination, and how you have to be careful while solving questions of circular permutation, or questions of grouping, or questions of bundle method or gap method. Okay, so you will remember it from the next time. Now let us move on forward and let us solve the next problem. Okay, so the next problem is saying that, alright, so the next problem says that, so the number of elements of the set A, so we have two sets. Okay, sets are present as A and B, and the number of set of A is basically equal to 5, and the number of elements in set of B is equal to 2, and these are saying that the number of subset of A cross B, okay, A cross B, such that each having at least 3 and at most 6 elements. Okay, now firstly you tell me that what is the cardinality. Okay, what is the cardinality of A cross B? So if you compute the Cartesian product of the set A and B, then what is the cardinality of this set A and A cross B? And that is basically directly given as cardinality of A into cardinality of B. Okay, because what is a Cartesian product of A and B? That are basically all the possible solutions, all the possible relation that can be possible from set A to set B. Okay, and that is basically then the number of elements in A cross B is equal to product of the individual elements, and that will basically 10 elements. Okay, so you will have 10 elements. Now in the subsets, okay, now the number of subsets of, okay, now you have to choose for the subsets of A cross B, okay, with elements greater than 3, greater than or equal to 3, but as well as it should be less than or equal to 6. Okay, so you have to choose for the subsets which has the total number of elements as 3, 4, 5 and 6. Okay, now this can be done in this particular fashion. Okay, subset with 3 elements. So the number of subsets with 3 elements is basically, out of this 10 element you have to basically choose for any 3 elements. Similarly for 4 elements, out of this 10 choose any 4. Similarly for 5 elements, out of this 10 choose any 5, and similarly for 6 element, out of this 10 choose any 6. And from here you will get the required cases, that is a number of subsets. Okay, therefore the required number of subsets, okay, required subset. Okay, now subsets questions are also important, because you will find that the question on cardinality of a set are also asked in frequently in JEE examination. That's why I took this particular problem, and the total number of required subset will be the summation of all this, that is 10c3 plus 10c4 plus 10c5 plus 10c6, and from here if you sum up this result you will find out this result as somewhere around is equal to 792. Now this is the calculation, that part is I am leaving up to you. So from here if you calculate, you will find the answer to this particular problem as basically equal to 792. Alright, so this was a quite a pretty simple problem, okay, but an important problem because these types of problems are actually getting repeated in examination. So I hope you will remember this for the next time. With this, let us move to the last problem. And the last problem says that it is again a problem which is quite interesting problem, okay. Now it is basically given as a series of a like a factorial sum is given. So if you look at the sum is basically 1 divided by 1 factorial by 50 factorial plus 1 divided by 3 factorial into 48 factorial plus 1 divided by 5 factorial plus 46 factorial and so on up to, okay, so on up to 1 divided by 51 factorial into 1 factorial. So you have to look for this particular sum. Now if you look at the sum, so let me, before doing the sum, what you can observe, okay, what important thing can you observe? If you look at the denominator, the both of the number which are present in factorial, and if you sum up both the numbers, the value is equal to constant. For all the terms, the value is equal to constant, that is equal to 51. So let me first multiply and divide by 51. So 51 factorial, if I divide and multiply with 51 factorial, the value is 51 factorial divided by 50 factorial into 1 factorial plus 51 factorial divided by 3 factorial into 48 factorial and so on up to the result over here, that is 51 factorial divided by 51 into 51 factorial into 0 factorial. Now instead of writing 1 factorial, I am writing this as 0 factorial. Why? Now because 1 factorial is also equal to 1 and 0 factorial is also equal to 1. So I am writing this as 51 factorial and 0 factorial. And now you will understand like what is the importance of doing so. So from here I can get, I will get it as 1 by 51 factorial into, and this particular term will become equal to 51c1, and this particular term will become equal to 51c0, and similarly this particular term will be equal to 51c3 and so on up to, and so on. If you find out, you will find that all of the terms are actually present. Okay, so all of the terms actually are present. Okay, and similarly there will be a term which has 51c51. Okay, and these are all the terms. If you look, these are all the terms that are present. Okay, no, I don't think that 51c51 will present, because once we took it at 51c0, then we cannot write it as 51c51. So better to write it as this way. Okay, and if you group these terms, okay, now if you group these particular values from here, if you group these values 1 by 51 factorial, and from here you will get the values as 51 factorial 50 plus 51c 45, sorry 48, okay, 51c 48 and so on. If you group out, and it will give 51c0, okay, up till 51c0. So what you observe is over here, sorry, 51c3, I am not writing it 51c3, instead I am writing it as 51c48. Now why I am doing so, you will understand, like in doing that you will always get the lower suffix as always an even number. In doing so, in changing these particular values, you will always get the lower suffix as a even number. And we have studied that whenever we sum up like nc0 plus nc2 and so on up to ncn, when n is an even number, the value is basically 2 to the power n minus 1. And from here the result you will get it as 1 by 51 factorial into 2 to the power 51 minus 1, and that is basically 2 to the power 50 divided by 51 factorial. And from this, the right answer to this particular problem will be option number D. So that is a pretty simple problem, but you need to understand like how you will basically approach this particular problem. Alright, so with this I come to the end. Okay, so that is the end on the take of the important 11 JEE main previous year problem on the chapter of permutation and combinations. So I have taken the important problems, okay, and also I have given one important homework problem for you to solve out. Okay, I will be waiting for your comments in your comment section. So if you are someone who is watching this particular lecture from this particular video, then I will request you to go to the playlist which you can find in the description box to today's video, and definitely start watching from the beginning. Alright, so that was my take on permutation and combination. Alright, so stay tuned for the next upcoming sessions, and the next session will be going to be on the binomial theorem and the remaining topics, that is matrix and determinant, and that's how I'll be finishing up the chapters of algebra, and then I will start with probabilities and statistics portion. So stay tuned for that, and thank you.